Dear students, welcome to my 7th class on module 3, Z transforms and difference equations. In this lecture video, we're going to discuss about how to solve difference equations using Z transforms. So now I'm going to solve all these difference equations by using Z transforms technique. So to solve the difference equation, we have to use the second shifting property. That is, Z transform of f of n plus 1 is equal to z into f of z minus z into f of 0. Second formula is Z transform of f of n plus 2 is equal to z square f of z minus z square f of 0 minus z into f of 1. Third formula is Z transform of f of n plus 3 is equal to z cube f of z minus z cube f of 0 minus z square f of 1 minus z f of 2. So this formula will be using to solve the difference equation. So first problem, solve yn plus 2 plus 6 yn plus 1 plus 9 yn is equal to 2 power n, given y0 is equal to y1 is equal to 0. So now, take the first given difference equation, that is yn plus 2 plus 6 yn plus 1 plus 9 yn is equal to 2 power n, with the initial conditions y0 is equal to 0 and y1 is equal to 0. So first thing is I am going to apply Z transform on both the sides for the given difference equation. So applying Z transform, so Z transform of yn plus 2 plus 6 into yn plus n 1 plus 9 yn is equal to Z transform of 2n. Expanding this Z transform, so we got Z transform of yn plus 2 plus 6 into Z transform of yn plus 1 plus 2 into Z transform of yn, sorry, it is 9 into Z transform of yn is equal to Z transform of 2 power n. So now I am going to use the shifting rule here, that is z square of y of z minus z square of y of 0 minus z into y of 1 plus 6 into z into y of z minus z into y of 0 plus 9 into y of z I am keeping as it is, and z transform of 2 power n is z by z minus 2. So now I am going to replace the initial conditions, these two initial conditions in this equation. So we got z square plus 6z plus 9 into y of z, and all the points will become 0 because of y0 is equal to 0 and y1 is equal to 0. So we got the equation like z plus 3 whole square into y of z is equal to z by z minus 2, and y of z is equal to z by z minus 2 into z plus 3 whole square. So now I am going to apply z inverse on both the sides to find the value of y. So applying Z transform on both the sides, we got Z inverse of y of z is equal to Z inverse of z by z minus 2 z plus 3 whole square. So now I am going to simplify this one by using partial fractions method. So take only y of z is equal to z by z minus 2 z plus 3 whole square, and take this z term to LHS. So we got y of z by z is equal to 1 by z minus 2 into z plus 3 whole square. So now we will expand this by using partial fractions method. So we got the equation like 1 by z minus 2 into z plus 3 whole square is equal to a by z minus 2 plus b by z plus 3 plus c by z plus 3 whole square. By taking LCM, we got 1 is equal to a into z plus 3 whole square plus b into z minus 2 into z plus 3 plus c into z minus 2. So now we will be finding the constants, that is ABC will be finding. So now to find the value of a, I am going to replace z is equal to 2 in this expression. So we got 1 is equal to a into 25 plus b into 0 plus c into 0. So we got a is equal to 1 by 25. Similarly, replace z is equal to minus 3. So we'll be getting 1 is equal to a into 0 plus b into 0 plus c into minus 5. So we got c is equal to minus 1 by 5. So now by comparing the coefficients of z square on both sides of the equation, we got a plus b is equal to 0 or b is equal to minus a. So we got b is equal to minus 1 by 25. So now all this ABC I am going to replace in this expression. So we got the equation 1 by z minus 2 z plus 3 whole square is equal to 1 by 25 into 1 by z minus 2 minus 1 by 25 into 1 by z plus 3 minus 1 by 5 into 1 by z plus 3 whole square. So now replacing this equation as y of z by z. So we got y of z by z is equal to 1 by 25 into 1 by z minus 2 minus 1 by 25 into 1 by z plus 3 minus 1 by 5 into 1 by z plus 3 whole square. So shifting this z to RHS, we got y of z is equal to 1 by 25 z by z minus 2 minus 1 by 25 z by z plus 3 minus 1 by 5 z by z plus 3 whole square. So now applying z inverse on both sides of this equation, we got z inverse of y of z is equal to 1 by 25 z inverse of z by z minus 2 minus 1 by 25 z inverse of z by z plus 3 minus 1 by 5 z inverse of z by z plus 3 whole square. So after expanding this, we got y of n is equal to 1 by 25 2 power n minus 1 by 25 minus 3 whole power n minus 1 by 5 n into minus 3 whole power n minus 1. So finally we got the equation like y of n is equal to 1 by 25 2 power n minus 1 by 25 minus 3 whole power n plus 1 by 1 by 5 into n into minus 3 whole power n we can write. Example number 2, solve yn plus 2 plus 4 yn plus 1 plus 3 yn is equal to 3 power n, given that y0 is equal to 0 and y1 is equal to 1. So same like a previous problem only. So for the given difference equation, we'll be applying z transform on both the sides. So after applying z transform, we got the equation like z transform of yn plus 2 plus 4 into z transform of yn plus 1 plus 3 into z transform of yn is equal to z transform of 3 power n. So now by applying shifting rule, we got z square y of z minus z square y of 0 minus z into y of 1 plus 4 times of z y of z minus z y of 0 plus 3 times of y of z is equal to z by z minus 3. So now I am taking the initial conditions, replacing y0 is equal to 0 and y1 is equal to 1. We got the equation like z square plus 4z plus 3 into y of z minus z is equal to z by z minus 3. So taking this minus z to RHS, we got z plus 1 into z plus 3 y of z. So expanding this one, we got z plus 1 into z plus 3 into y of z is equal to z by z minus 3 plus z, or z plus 1 z plus 3 into y of z is equal to z by z plus z into z minus 3 by z minus 3 by taking LCM here. So finally we got y of z is equal to z plus z square minus 3z divided by z plus 1 z plus 3 into z minus 3, or we got y of z is equal to z square minus 2z by z plus 1 z plus 3 into z minus 3, or y of z is equal to z into z minus 2 divided by z plus 1 z plus 3 z minus 3. So now I am going to expand this equation by using partial fraction method first. So take one z term to LHS. So we got y of z by z is equal to z minus 2 by z plus 1 z plus 3 z minus 2. So expand this now by using partial fractions method. So we got z minus 2 divided by z plus 1 z plus 3 z minus 2 is equal to a by z plus 1 plus b by z plus 3 plus c by z minus 3. So take LCM over here. So we got z minus 2 is equal to a into z plus 3 z minus 3 plus b into z plus 1 z minus 3 plus c into z plus 1 z plus 3. So now we'll be finding ABC. To find a, make b and c 0. To find b, make a and c 0. To find c, make a and b 0. So to find a, I'll be replacing z is equal to minus 1 here. So we got minus 3 is equal to a into 2 into minus 4 plus b into 0 plus c into 0. We got a is equal to 3 by 8. Put z is equal to minus 3, we get minus 5 is equal to a into 0 plus b into minus 2 minus 6 plus c into 0. So we got b is equal to minus 5 by 12. Put z is equal to plus 3, we get 1 is equal to a into 0 plus b into 0 plus c into 4 into 6, we got c is equal to 1 by 24. So now replace all this ABC value in the previous equation. So we got z minus 2 by z plus 1 z plus 3 into z minus 3 is equal to 3 by 8 into 1 by z plus 1 minus 5 by 12 into 1 by z plus 3 plus 1 by 24 into 1 by z minus 3. So therefore we got y of z by z is equal to 3 by 8 into 1 by z plus 1 minus 5 by 12 into 1 by z plus 3 plus 1 by 24 into 1 by z minus 3. So shifting this z to RHS, we got y of z is equal to 3 by 8 z by z plus 1 minus 5 by 12 z by z plus 3 plus 1 by 24 into z by z minus 3. Now applying inverse z transform on both the sides and simplifying that. So we got the equation like z inverse of y of z is equal to 3 by 8 z inverse of z by z plus 1 minus 5 by 12 into z inverse of z by z plus 3 plus 1 by 24 into z inverse of z by z minus 3. So on simplifying this, we got y of n is equal to 3 by 8 minus 1 power n minus 5 by 12 minus 3 power n plus 1 by 24 into 3 power n is a required solution. Example number 3. Solve yn plus 2 plus 4yn plus 1 minus 5yn is equal to 24n minus 8. Given y0 is equal to 3 and y1 is equal to minus 5. So we'll be applying z transform for the given difference equation first, and so and after applying shifting rule for the given equation, so we got the equation like z square plus 4z minus 5 into y of z minus 3z square plus 5z minus 12z is equal to 24z minus 8z into z minus 1 by z minus 1 whole square we got. And on simplifying this further and shifting this term to LHS, so RHS, we got z plus 5 z minus 1 into yz is equal to 24z minus 8z square plus 8z by z minus 1 whole square plus 3z square plus 7z. So on simplify this further, we got the equation y of z is equal to z into 3z cube plus z square minus 9z plus 39 divided by z plus 5 into z minus 1 whole cube. So now same like a previous problem only, we'll be expanding this equation by using partial fractions method. So first take one z term to LHS. So we got y of z by z is equal to 3z cube plus z square minus 19z plus 39 divided by z plus 5 into z minus 1 whole cube. So expanding this by using partial fractions method, we got the equation like 3z cube plus z square minus 19z plus 39 divided by z plus 1 into z minus 1 whole cube will be equal to a by z plus 5 plus b by z minus 1 plus c by z minus 1 whole square plus d by z minus 1 whole cube. So expand this by taking LCM. So we got this equation. So now we'll be finding a, b, c, d values. So by replacing z is equal to minus 1, here we got a is equal to 1. By taking z is equal to 1, we got d is equal to 4. By taking only z cube coefficients, so we got the value of b is equal to 2, and taking z is equal to 0, we got the value of c is equal to minus 2. So now replace all this: a is equal to 1, d is equal to 4, b is equal to 2, and c is equal to minus 2 in this expression. So we got the equation like this, that is y of z is equal to z by z plus 5 plus 2 into z by z minus 1 minus 2 into z by z minus 1 whole square plus 4 into z by z minus 1 whole cube we got. So now for this expression, we'll be applying z inverse on both the sides. So after applying z inverse and simplifying that, we got the value of yn is equal to minus 5 whole power n plus 2 into 2 minus 2n plus 4 into n by n into n minus 1 divided by 2. So expanding this, we got y of n is equal to minus 5 whole power n plus 2 minus 2n plus 2n square minus 2n. So therefore we got y of n is equal to minus 5 whole power n plus 2n square minus 4n plus 2 is the required solution. Thank you.